Show you all the answers. You can. Some of them I have work for, the more complex ones, and some I do not. Some I just have an answer for. So again, if you wish to see it all done all the way through, just stop me and say, "Can you show me that one?" 32. Where are you? 32. There you are. Sure. There we go. There is the first one. I will highlight in blue. That is how you do it. There was work for that one, obviously. Duh. Oh. And then there. And 66, of course, is obviously already simplified because it is 11 times 2 times 3 and there is no pairs. Does anybody need to see any more of those than what is shown there? Please remember, if you did not bother to do this work, you can check this online. I do not want you copying this all down right now if you did not do it. Everyone is okay? Once, twice, thrice? Okay. There. Now, this question, if you simplify 20 over 6, which of course you could to negative 10/3, that's fine. But I've noticed that most people tend to leave it there. But you can simplify that as well if you wish. There. And 341 is not a prime number, but its only factors are 11 and 31, which are prime numbers, so you can't make 341 any simpler anyway. Everyone okay with page 32? Once, twice, thrice. Lovely. Page 35. That was the next thing you had to do, yeah?
Yeah.
Okay. 48 root 7. The root of 4,608. 24 root 7. And this one got a little complicated. If you got to here and stopped because you couldn't remember exactly how to multiply radicals, because this much we did in grade 10, I'm perfectly happy if you stopped there. If, however, you continued onwards, you found that the answer was the root of 168, or 168 root 14. But if you stop there, I'm perfectly happy with that because there's no shame in forgetting how to multiply radicals because you haven't done it for a year. Which is why we're going to do that today. Okay? Okay. $36. There. Please remember, order does not matter here. You may have negative 2 root 5 plus 10 root 2. You may have negative 11 root 6 minus 9 root 7. I do not care about order. Okay? Oh, yes. D. Where? D. This one? Let's see. 6 minus 15 is negative 9. So where are you finding my fault? 6 root 7. 30, I don't think so. 36 times 7, 2, carry the 4, 7 times 3, 252. So 36 root 7, so yeah, that should be 12, shouldn't it? Because a 6, that's 36 times 7, and I bring out a 6, so that should be 12. Nice! Good job. 12 minus 15 is indeed negative 3. Well done. Anything else? And there. And that should be it, yeah? Everybody good? Oh, Lucas. F. 51. 57 would have a little cross. Remember, my 7s have one of those for just such an emergency. Like Foghorn Leghorn. I keep my feathers numbered for just such an emergency. Nav, I say Nav.
I have a question. Like, on the test, do we have to get exactly what you get, or do we just have to get an answer that is equal to?
What do you mean exactly what I get?
Because at the bottom is the one. Right. So at that one, I got 5 and 12 underneath the square root plus square root of 96. Would that work? I did the exact same stuff that you did to me. Like, my thing was stop.
What?
Okay, like.
There's nothing you can do with the square root of 36 other than make it 4 root 6. But that's wrong. Because the square root of 96 simplifies. And the square root of 12 simplifies.
But the final answer that you get is similar to yours.
But it's not.
Because that's...
But it's
4
not.
times 6 is what, 96?
No. It's not.
Wow. Okay.
You have 5 root 12 plus root 96, yes?
Yeah.
Well, root 12 is 4 times 3. So it's 10 root 3. And 96 is 16 times 6. So it's 4 root 6. You have an answer. You don't have the answer. Would I give you credit? Yes. Would I give you full credit? No. Because the answer is always to be simplified. Okay? So while you did indeed have an answer, and it was correct, it was not the answer. All right. Everybody okay with adding it? Oh, yes. Pardon? Question which? A question on page 36. Which one? This one. Okay. So we simplify everything, right? So since it's cubed root... Oh, one sec. Let me get my fancy red circle back. There we go. So since it's cube root, we're looking for cubes, right? So this is 64 times 2, yeah? Cube root of 64 is 4. Cool? This is 375. 125 times 3, right? 125 is a 5, so out comes the 5. And I already had a 3 out there, so there's my 15. Cool? 27. 27's cube root is 3, so out comes a 3. 21. Good? Okay. 250 is 125 times 2, so out comes a 5. 10. 432 is 216 times 2, so out comes a 6. 6 times 5, 30. And 2,000 is 1,000 times 2, Cube root of 1,000 is 10, so out comes a 10. Oh, forgot to make that 80. Whew, what an idiot. Good gravy. So now I got to check everything. 21 is good. Root 2. 4 minus 10 is negative 6. Minus 30 is negative 36. Plus 80 is 54. 44. 54. 44. 44. And then root 2. Oh, that was the root 2. 44 root 2. And it's plus 44, right? And the root 3's was 15. Just 15. Thank you, Jenny. Now, guys, please, 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 please look at how easy it is to screw these up. Right? All I did, I even remembered to make it root 2. I just forgot to take out the 10. And then I did everything else right. Please see how easy it is to do this if you rush. There is no prize for finishing first. Okay? I did these this morning, racing to get them done before you got here. And now, what was my prize? Embarrassment. Okay? I mean, I'm not really embarrassed because, as you all well know, when you're this funny, good-looking, and intelligent, you have to have mistakes somewhere along the line so all you regular people can feel comfortable being in a room with me. I understand. But that doesn't fix the fact that I made errors that you have to catch because I'm in a rush. There is no prize for it at all. Okay, this is not the Olympics. Okay? All right. Now, still, now we're all good? That's not too bad. 2 mistakes in the whole page. Let us move on then, cabbages, to page 37. Now, we're going to do something a little weird today. We're going to do a little bit of talking, a little bit of work. Then I'm going to talk a little bit more about dividing, and then you're going to do a little bit of work. Together we'll do a little bit of work. Then I'm going to shut up and let you do some multiplying and dividing. Okay? Okay. So the first thing we got to talk about is multiplying radicals. There's a few subtle nuances to multiplying radicals, but the most basic thing is also exactly the same as It's not a sound you often hear here. The trains are pretty far away. That's not a train. No way. I've been teaching it for 8 years. I don't remember ever hearing a train whistle.
It's a car with a train whistle. My uncle hooked up the train whistle to his car.
I don't think that's a train. Whatever. All right. Now I'm all discombobulated. What are we talking about? Oh, right. At its most basic, multiplying radicals is exactly the same as multiplying coefficients and variables. Okay? So, start from what we know. If I were to take this, 3x, and multiply it by 4x, I get what? 12x squared. Why do I get 12x squared, Lucas? Because it's 3 times 4, and then it is x times x. Yes? So the only changes that happen are 3x times 4y. What do I get? 3 times 4, and then x times y. Everybody cool? Yeah? Okay. Radicals are the same thing at their basic level. All right? So if I have a radical with a coefficient 3, root 3 times 4 root 5, what do I really have there? 3 times 4, and root 3 times root 5. Oops, I just gave it away. Root 5. To get 12 root 15. Is everybody cool with that? Yeah? Okay. That's all you need to know. If you can do that, you're good. Now, of course, as Nav and I were just discussing, sometimes, just like in adding and subtracting, you don't get to stop there. And I'll give you an example of what I mean. If I have 3 root 6 times 3 root 3, what do I get there? Don't show me all the work. Just tell me the answer. 9 root 18. Now, is that the answer?
No.
It is indeed an answer, but in math class, we don't like anything that isn't in its simplest form, yes? So at the end, we simplify. This is 9 times 2, so what comes out? 3. There was already a 9 out there, so this is really 27 root 2. Is everybody cool with that? Now, of course, if you stop listening right now, I got it, no problem. Great, you've got it, no problem. Until I give you a question like this. 3 root 54 times 4 root 63. Now that answer is obviously 12 root 3,402, isn't it? But that would be stupid, wouldn't it? Why? Exactly. Simplify before. Just like when you're multiplying fractions, you do that crissy-crossy thing, right? 16 over 18 times 27 over 32. You don't do 16 and you don't do a cross. You cancel first, right? Same thing here. You would simplify these. And you would get 9 times 6, 9 times 7. So you would get 9 root 6 times 12 root 7, which would be 108 root 42. And that's where you'd stop, because of course you cannot simplify 42, because it's 2 times 3 times 7. But that is a lot easier to deal with than the square root of 3,402. Does everybody understand? Now that, ladies and gentlemen, is all there is to basic multiplying of radicals. But I remind you, all the other rules you have ever known about multiplying anything in math class apply. What do you mean by that, Mr. Myers? Everybody needs to remember this. What do I do there? Distribute. So the answer is x squared plus xy. Okay, and you all need to remember this. FOIL, right? What's the answer there? XA plus XB plus YA plus YB. Double distribution. Those rules still apply, but now you've got radicals instead of regular numbers. Okay? There's nothing new. Now, I'm planning to go over foiling again because it is always helpful. If you are comfortable with FOIL, do not write this down. If you would like to write it down, write it down. 6x minus 3. Actually, I'm going to make it the hardest kind possible. 5x plus 4y. There are plenty of shortcuts to FOIL. Learn them yourself. The way that always works is actually doing it. At your guys' level, by grade 11, you can probably do it in your head. But since you haven't done it for a year, I recommend the first couple of times actually doing what I'm about to do. Draw an arrow, write an answer. 30x squared. First. Draw another arrow, write an answer. Plus 24xy. Draw another arrow, write an answer. Inside. Now here's what I like to do when I am doing FOIL. I'm on a new term. I go to a new line. -3 times 5 is -15xy. And I put them right together. So collecting your like terms is not difficult because you've got them grouped already. And then last, minus 12y squared. Then I collect my like terms. 30x squared, 24 minus 15 is 9xy. 0 minus 12 is -12y squared. Does everybody remember how to FOIL? Okay. FOIL is just the acronym for it. It's actually just double distribution. You just distribute the x term, the first term into both, then the second term into both, and collect your like terms. You've done it a million times last year. You'll pick it up again. It's no problem. It's just not something there's a lot of call for in real life. Everybody cool with that, Nav? You good now?
Yeah.
You remember? Good. Okay. So this first one's super easy, right? It's just like our very first example. There's two coefficients, there's two radicands. Coefficients go with coefficients, radicands go with radicands. So my answer is -35 root 24, right? Now if I stop there, are we okay? Kinda. 24 gets simpler. What's 24? 4 times 6, right? What's the square root of 4? 2. So what comes out? 2. What's already out there? 35. So what's the answer? -70. And what's the radicand? 6. Gouda? Great. Now, could I have simplified this 8 in the first step? Is that okay? Sure it is. I could simplify this 8 right now and break it down into 4 times 2, yes? What comes out? 2. So what I really have there is root 2 times 6 root 2. Yes? Everyone agree? Okay. So my coefficients go with coefficients. What's the coefficient here where I don't have a coefficient? 1. So 1 times 6 is 6. And root 2 times root 2, what is that? 2. Does everybody remember that from grade 10? If you square a radical, you get the radicand. If it's a square root, right? Root x times root x is root x squared, and it is x. Okay? Everybody remembers that? We'll talk about what happens with higher powers later, but for now we're here. So this is really, technically, 6 root 4, isn't it? And what is root 4? 2. So this is really 6 times 2. So it's really 12. Everybody good? All right. Now, the next one's slightly tricky because it requires you to remember a bunch of stuff. It requires you to remember your exponent laws. It requires you to remember radical rules. And it requires you to remember what happens to a negative that's part of your base. What's happening here? Now, I know you could all tell me the answer. I want to know why. Lucas, what's happening here? It's -6, negative root 6, times negative root 6, isn't it? Okay. Why did I include the negative? Because of these brackets. So a negative times a negative gives me what? Positive. And root 6 times root 6 gives me what? 6. So what's the answer? 6. Good? Okay. Look at D. What is being squared? the 4, and the root 3. So what do I have there? I really have 4 root 3 times 4 root 3, which is really 4 times 4 and root 3 times root 3, correct? 4 times 4 is 16 times root 3 is 3, so it's really 48. Now, guys, right now in our notes, I hope you understand why I am writing all this out. Do I need to see all that on your tests? By the time you've gone through all your practice, all our quizzes, all your review assignments, do you think I'm comfortable with you just telling me that it's 48? Understand? I'm willing to, it'd be really nice to see this part. That'd make me really happy, especially if it's no calculator section. Cool? Everybody okay? All right. E is where it starts to get weird. F is where it starts to get really weird. So let's go through E and F together, and then we're going to stop with multiplying for a moment. And I'm going to let you guys do page 38. Then, I'm going to let you guys do 38 and 39. Then we're going to talk about dividing, because you're tired of listening to my voice. Okay, so let's look at E. What would you guys do first with E? Lucas, what would you do first? You would simplify the 5 root 8? Yeah, I probably would too. So what is that? That's 10 root 2 times 3 root 2 plus 2 root 3 minus root 5. Everybody okay with that? Did we need to simplify that root 8? Not really, because 8's a small number, yeah? We're smart kids. We could have done 8 times 2, 8 times 3, and 8 times 5. We could have. It's no big deal. Right? So now what do we need to do? Now we have to distribute, right? It's not FOIL. It's just a single distribution. But again, I recommend doing it step by step. Do the first one. 10 times 3 is 30. Root 2 times root 2 is? Root 2 times root 2 is? 2. Plus 10 times 2, 20. 2 times 3, root 6. Minus 10 root 10. Any simplifying to be done there? 30 times 2 is 60. Do either of them simplify? Nope. So we're done. Everybody cool? All right. Now this next one is where it starts to begin to get actually tricky, right? This is FOIL. Okay. So just do it step by step. First, outside, inside, last. Write out the numbers. Simplify all the stuff you already know what to do. Okay? So, first, what's 8 times 9? 72, and 2 times 5 is root 10. Everybody cool? What's the next term going to be? 48 root 20. Everyone still cool? Okay. What's the next term going to be? Negative 45 root 5. Now, Myers, you said to stack them right there. Why am I not stacking them here? Because they're not like terms yet, are they? And what's my last term? Negative 30 root 10. Now, do you see, you've got a couple of choices here now, right? There's some like terms we could collect, and there's some stuff to simplify, right? When we get later on in our practice, we could probably do these both in one step. But right now, we're at the very beginning. So what do I recommend? I recommend doing one of the two things. Do each step. So what do you guys want to do now? You want to collect your like terms or do you want to simplify? It doesn't matter. It doesn't matter which one you do. I'm going to collect my like terms. And I see that there's a root 10 and a root 10. Right? So I'm going to go ahead and collect them to get 42 root 10 plus 48 root 20 minus 45 root 5. Now I look at that and I say to myself, self, 10 and 5 are done, aren't they? But 20 can simplify, can't it? What does 20 become? 4 times 5. Does 4 have a square root? What is it? So what comes out? 2. So now I've got 42 root 10 plus 96 root 5 minus 45 root 5. And that has led me to a final step. There's one more like terms, isn't there? 96 minus 45. What does that give me? What does that give me? 51. 96 minus 40 is 56. 51. Root 5. Who just got confused? Huh? Okay.
I'm not necessarily confused. I'm more wondering why we can't simplify 42 and 10.
Because 10 is 2 times 5. There's no pairs. Cool?
Yeah.
Everybody good? All right. Now, G and H bother me because often kids do this wrong. Okay? What does this mean? The whole thing is squared. It is not 5 root 3 squared minus 4 root 6 squared. It is not that. What is it really? 5 root 3 minus 4 root 6 times 5 root 3 minus 4 root 6. Okay? So you guys try working through that one. Go slow, figure it out. You can go step by step because there's nothing to simplify at the beginning. Why did I stack these ones? Because they were like terms. Right? Because 3 times 6 and 6 times 3 both gets me 18. Can I stop there? Of course there is. But why would I teach you a shortcut that only works sometimes? Learn your own shortcuts. The reason I don't, Jenny, is because every time I teach a shortcut, a kid tries to apply the shortcut where it shouldn't be applied. And then they try and make the question work for that shortcut rather than the other way around. Okay? If I gave you a shortcut to the mall, but I told you to meet me at Rick Hansen Secondary School, does the shortcut to the mall help you? No. So yes, there is a shortcut there. You can add and subtract and do all that fancy stuff, but that doesn't help you over here. So feel free to learn them. You will not learn them from me. Oh, I know, right? Can I stop there? No, why not, Michaela? Simplify what? Root 18. What is 18? 9 times 2. So what comes out? Shaq's already said it, a 3. 171 minus 120 root 2. Is everybody good? Okay. All right. Now look at H. It looks scary, doesn't it? Do you think anything changes? No, of course not. This squared means what? Everything. So I'm going to just write this again. 2 cube root 54 minus 3 cube root 4. Now, you guys are smart kids. Is that a coefficient? Yep. Is that a coefficient? Yep. 2 times 2, 4. Easy. Do that in our sleep. Is that a radicand? Yep. Is that a radicand? Yep. 54 times 54. Is that a number you wish to deal with? Anybody? I don't want to deal with 54 times 54. So when the numbers get to somewhere that we don't want to deal with, what should we do? Simplify. What does 54 break down into? Remember, though, we're not looking for squares anymore. We're looking for cubes. 27 times 2, yes? What's the cube root of 27? 3. So what comes out? 3. So what I've really got is 6 cube root 2, don't I? Everyone okay with that? Minus 3 cube root 4. Then I come over here, and here I've got the same thing, right? 6 cube root 2 minus 3 cube root 4. Shouldn't have put that first bracket there. Now, Jenny knows there's a shortcut. And there is. Right? What is the shortcut? I'm not saying it. Jenny will tell us. Yeah. A squared minus 2 of the other 2 plus b squared. Everybody cool? A squared, what is 6 times 6? 36. Cube root what? 4. Now, you guys should be saying to yourself right now, but Myers, you said if we do the same radicand times the same radicand, you get the radicand, don't you? Except these are cube roots. Right? So I would need to cube to get rid of it. Understand? So if it was the 9th root, it would be, I'd have to do 9 of them to get rid of the radical. Understand? So this just follows the same rules. Cube root of 2 times 2. Okay? Then cube root of 2 times cube root of 2 times cube root of 2 is 2. If it's the 4th root, 4th root of 2 times 4th root of 2 times 4th root of 2 times 4th root of 2. Okay? Everybody cool with that? The rules don't change. There was our a squared. Now we need 2 ABs if we're going to follow Jenny's shortcut. So AB is negative 18 root 6, yes? Right? And there's 2 of them. So it's minus 36 cube root 6. Yeah? Yeah, because there's 2 of them.
4 and 2.
Oh, sorry. It's 8. 2 times 4, right. Everybody still cool? And then b squared is plus 9 cube root what? What's the last one going to be? 16. Now, are we happy there? Not quite, because there's simplifying to be done, yes? Is there any cube roots coming out of 4? No. So that's staying the same. Does 8 have a cube root? What is it? 2. So what comes out? 2. So what's that become? Negative 72. Does 16 break down? To what? 8 and 2. What's the cube root of 8? So what comes out? 2. So I got plus 18 cube root 2. Now, there is an answer. In a perfect world, we would put them in descending order. So in a perfect world, it would be 36 cube root 4 plus 18 cube root 2 minus 72. Do you think I care? Couldn't care less. If you get to here, I'm already doing cartwheels. If you get to here, I'll finish with a nice round off right at the edge of the floor design, and I won't even do that little stumble thing that they do. Or that thing they do where they fall but then pretend like it's part of the routine. Right? Like everybody knows it's not, but the judges can't fault them because it's technically a gymnastics move, a fall. If you fall to a support, it bothers me. But what are you going to do? Right? Every judge sport sucks. Is everybody good? Yeah? Okay. I would like to shut up my pie hole. What time is it? Why don't you guys do 38 and 39? And we'll see where we are at the end of that. See if I want to continue or if I want to shut up. Okay? Okay. Giver. 38 and 39. I'm going to pause this. So this is 5 minus 4, which is 1, right? Why does this work? Because root 5 times root 5 gets me 5. Plus 2 root 5 minus 2 root 5, they drop out. And 2 times 2 is negative 4. So here again, the middle term drops out, doesn't it? Because it's plus minus. So this is 16. Now I'm going to write this out properly. 16 root 9, 3 times 3, minus 25, right? What's the root of 9? 3. 48 minus 25, 23. What happens here? The middle term drops out again, right? So I get 64 root 4. That's that one. Minus 25 root 36. That's that one. Which is 128, because out comes a 2. And minus 150. Because out comes 6. 128 minus 150 is what? Negative 22, not 32, dummy head. Middle term drops out. First one, 81 root 25. Second one, minus 36 root 100. Out comes a 5, 405. Out comes a 10, minus 360. And what do I get? 45. Cool? All right, you guys should be able to handle the next couple. And I think I think this will do. I think we'll stop. We won't do any division till tomorrow because tomorrow's a short day anyway. And division, yeah, we'll take care of all of division tomorrow. I lie. We'll take care of some of division tomorrow. But I would like to show you these right answers today. So let's make sure this gets done in the next 20 minutes. Cool?
Thanks for us in the first thing. Really?
Yeah.
I think God knows.
One of them is over in front of your head. Yes.
I'm busy. You know that. You know what?
Do any of you ever have the problem where you grab the wrong socks? Because you've got other people in your house and everybody has similar looking socks.
My dad takes my socks.
And you grab the socks that you think are yours, but they really belong to your 12-year-old son. And then you wear them, and then they fall down your feet. And you're walking along, and you realize that your socks are around your toes. Then you got to pull them up, and then you realize it's only 9 in the morning. You're going to have to do that all damn day. Huh? You're right. Screw my smartphone. I hate it, man, because nobody folds laundry but me, and I hate folding socks. So I just grab socks and put them together. And as a result, I'm wearing tiny, tiny socks. Okay, I would like to talk less, so I'm going to start doing some of these up here. You can check your own work in a moment. Yeah? Well, I just recorded that whole thing about socks.
Yeah.
Oh, well. Now, I would like to call your attention to these two questions. How many people got to there quite comfortably? I'd like to think everyone, yes? Our next unit is going to be a review of factoring from the 10th grade. Right now we're cool, right? But next unit, you're going to take these one step further. What are you going to do there? Lucas. Oh, what was your question? Root 48 minus root 16. No. No, because they're not the same radical. That's adding and subtracting radicals. We just did 2 pages on that. They got to be the same, remember? So, what can I do there? What can come out of there? 4. I would divide this by 4, and I would get root 3 minus 1. Next unit. Everybody understand? Everybody remember that? So what would come out of here? 4 again. And I get root 15 plus 10 root 2. Everybody cool? That's your ultimate goal with these. I'm going to start sprinkling them in throughout your work to remind you of our next unit. Okay? If you're here in blue, I'm happy right now. But be aware there's more to go. Cool? Okay. Can I go on to the next page here? Has everybody had a good look? Okay. Can I call your attention to this guy right here? I did something a little differently here. I didn't simplify till here. Then I simplified 9, 3, 4, 3, and then I pulled out everything. Does everyone see what I did there? I could have simplified the 27 and the 12 up here, but that would have been the only simplifying I needed to do. The rest was so easy, I just did it in my head. And then here, I just left it as 27 and 12 and broke it down. Then I took out a 3, another 3, and the square root of 4, which was 2. And 3 times 3 times 2 was 18. Cool? Got 18 minutes left in class. I lie. 16 minutes left in class. We'll get this done, and then you'll have no homework tonight. And please remember, if you don't get this done in class, this is all recorded. You can check it tonight at home. I've been recording my work along here as well. You guys have not seen your powers test. You've seen the multiple choice. You haven't seen the open-ended. So I'm going to stop this now. I'm going to let you see the open-ended part, which was out of 16. I'll bring it around. This is all recorded, so you can